Okay, pencil. Here we go. All right, so quadratic applications. Yesterday you learned some stuff to use on the calculator. Honestly, I haven't gone over that, but I'm going to show you how I would do it, and hopefully the stuff from yesterday will actually refine my methodology here. So, at the circus, clown is fired from a cannon. The equation represents the height at any time is h equals 8t minus 5t squared, where h is the height of the clown and t is the time in seconds. How high is he above the firing point after 0.6 seconds? Okay, so I go to our handy dandy calculator and I put 8x minus 5x squared in, and I graph it. And we're not seeing a whole lot, so I'm going to go to zoom 6, which is our standard window. See if we see any more. There's that. All right, so I want to go from 0 to about 4. And then I want to go from 0 to about 5 to blow it up a little bit. So window, 0 is our minimum, 4 is our maximum, scale factor 1 is fine, y minimum I want 0, y maximum I want 5. Let's see what that does. Graph. Much better. Okay, so we can clearly see our graph here. And we want the firing. How high is the clown above the firing point after 0.6 seconds? Okay, so I go to my table. Well, this is counting by whole numbers, so that's not going to help me a lot. So I need to go to second window, which is table set, and I'm going to tell it to start at 0, and I'm going to tell it to count by 0.1. Okay, this is asking for 0.6, so I'm going to tell it to count by 0.1. And I'm also going, well, you know what? We can leave that at 1, I think, and we can just go to ask. We can change the x value, the independent value, to ask, and then we should be able to put in exactly what we want. So second table. All right, I want 0.6. So that means he is 3. Height of the clown. Does it tell me what units? Doesn't tell me what units. So he is 3 unit. Oh, there we go. Here's a hint and another question. He is 3 meters above the ground when you plug in 0.6 for x. Now, the way you would do that by hand is h equals 8 times 0.6 plus, or minus rather, 5 times 0.6 squared, and you would get that. Okay, but this allows the calculator to do it for us. So there's a minus there. All right, when will he be 2 meters above the firing point? All right, so let's go back to y equals. Let's go back to table set. I want to leave my table set there. Second window, okay? Count by ones. Now, let's go back to auto so we can get an idea. All right, 2 meters above the ground, okay? Remember, h is your y. Y equals 8x minus 5x squared. Okay, so I'm looking where it's going to be 2 meters above the ground. And the only place that's going to happen is between 0 and 1. All right, so I'm going to go to my graph. All right, 2 meters, we're right here. If I had to guess, it would be about a half second, but we're also going to get 2 meters over here. Okay, so we need to look at how our graph is being talked about, and I'm going to go back to table set, and I am going to change that to 0.1. Now let's look at the table. Okay, and I want whole numbers. because we don't, in an application problem, you don't deal in the negatives. Okay, all right, I'm at whole numbers. Here's 0, 0. He gets fired out of the cannon. Okay, we want where he's going to be 2 meters above the ground. Ooh, 0.3, that's really close. 0.4, we're only 5/100ths away here. Here we are 4/10ths away. So it's going to be like 0.32. All right, so plus or minus 0.32. So let's do this. Let's go to the graph and let's go to trace. Trace. Okay, and I've got to find my cursor. 1.78 should be showing up here before too long. Ah, there we go. All right, I want it to be 2 over here for the y value. There's 2.06. That's pretty darn close. That's 1.27. Plus or minus 1.27. Okay. And then I keep moving back over to find the place where it hits 2 right here also. And 1.93, 2.14, 1.9, 2.14, 2.1. So, Boo, I'm at school working. What's up? I know. I'm trying to finish up my keys. I've got a video going. Oh, okay. Well, congratulations. Wonderful. Where's Broussard? Oh, okay. That's not terrible. Yeah. 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 But no, that's silly. But let me let you go. I got a video going right now. Okay, I'll call you back later. All right, love you. Bye. Okay, so right here is the 2 meters above the ground, and at that point, our x value or our time is 0.34. And if we went to the 1.93, that's 0.29. So really, this was a little bit high. 0.3. Well, no, it wasn't. That actually was a good reference. 0.34. So when y was 1.9, it was 0.29. Okay, and I had 0.32. So this is not going to be an exact science right here, but it'll work. Okay, all right. When will he be back at the level of the cannon? Well, the cannon is ground 0, right? So y is 0, the height is 0, because it didn't give us a height of the actual cannon. So what I'm doing is I'm scrolling back over. Okay, that's negative 0.13, 0.2 is 1.57 seconds, and we go negative at 1.61. So I'm going to call it 1.6. 1.6 seconds. Okay, now if you did it mathematically, you would take the equation, because the height is 0, like I said, and we have 8t minus 5t squared. So we factor it. We pull a GCF out, which is t. So we have 8 minus 5t. And then you set each factor equal to 0. So there's 1. And which is the beginning at time equals 0. He's in the canon. Okay, and then this one, 8 minus 5t equals 0. Negative 5t equals negative 8. So t equals positive 8 over 5. So I can quit. Which is 1.6 seconds. So this is the final time that he's at on the ground. In the cannon, and then he got shot out and he hits the ground again. All right, now, so a golf ball is hit high into the air. The path of the ball is given by this equation, where h is the height of the ball and t is the time in seconds. How high is it after 3 seconds? Okay, so go to y equals, clear that out. 33x minus 5x squared. Go to the table. Oh, I want to change. I want to go back to second table set. I want to change to 1. And we'll change that to negative 1's fine. Now go to table. So 3 seconds, 1, 2, 3, is at 54 feet. Or meters. They're talking meters again here. If you're wondering what the panning is, I brought my dog with me up here to the school. Okay, when will the ball be 29 meters above the ground? Okay, so I'm looking at this. It's going to be between 1 and 2 seconds and much closer to the 1 second. Okay, as it's going up, then it's going to hit its maximum height and then it's going to fall down. Okay, so so I want the time for 29 meters. So the first time is between 1 and 2 seconds. And the second time is going to be, let's go to the graph. And we'll adjust our graph again. Zoom 6. Let's see what that shows us. Okay, so I want to adjust my window. 1, 2, 3, 4, 5, 6, 7. I want to go, the 10 is okay, but I need it to be a lot taller. So window, we're going to start at 0 for the x's. We're going to go to 10, so that's fine. But for the y's, I want to start at 0, and I want to go to, I don't know, let's try 100 and see what that does. Okay, so I'm going to go back and I'm going to refine that a little bit. I want my y max to be like 75. Okay, so I got that. Now I can trace, or actually second trace, and I want a value. I want it to be 29. Let's try 29. Whoops, 29. Oh, it didn't want that. Okay, second trace, 1 for value, and I'm going to put 1.5. Okay, I'm at 38.2925. That's not going to help me a whole lot. All right, so second trace, value 1, and I'm going to do 1.2. Enter. That's 32. Okay, so I'm getting closer. Second trace. Oh, wait. That's my x. Yeah, that's right. So second trace value. And I did 1.2, so I want to do 1.1. Let's see what that does. 30. Okay, so 1.05. Second trace, 1.05. 1.05. 29. There we go. Okay, so 1.05. And then the second time it's going to hit 29 meters, right here is going to be, graph, 29 meters was about here. So that's 1, 2, 3, 4, 5, 6. Around 6 seconds, probably a little less. So second trace value. And let's do 5.5 and see what happens. Ooh, that's close. All right. I want 29 though, so it's going to be a little bit further this way. So it's got to be more than 5.5. Let's do second trace 1.55. Oh, that didn't work right. 1 second trace 1.55. Enter. And we want 29 meters. So I'm still too high. All right, so second trace 1.54. It's 39. Oh, why am I doing 1.54? I should be doing 5.54. Second trace 1 for value, 5.54. There we go. That's close enough. And 5.54 seconds. Okay, so the other time was between 5 and 6 seconds. Okay, when will it be 60 meters above the ground? So I'm just going to go to my table. And the highest that it's showing here is 54 at about 3 seconds. So let's go to the graph. And let's do second trace. Highest point would be a maximum, 4. And then we go to the left of 4, the left of the highest point on the graph right here for the left bound. We go to the right, somewhere to the right of the highest point for the right bound. When it says guess, you just hit enter. And its highest point is 54.45 meters. So it will never hit 60 meters above the ground. Okay, when will it hit the ground? All right, so let's look at the graph. 1, 2, 3, 4, 5, 6. A little past 6.5 is what it looks like. So I want to know an x-intercept. Let's look at our choices here. A 0, x-intercepts, zeros, solutions, answers, roots. They're all the same thing. It's where it hits the x-axis. So I want 0, number 2. Okay, and I do left bound, which would be somewhere above it. Enter. Right bound, I have to go a little bit below it. Hit enter. Okay, I see that it did take it even though it's off my screen. Okay, and then when it says guess, I hit enter again. And it says 6.6 seconds. Okay, so turn over. The area of a room is represented by this equation. Okay, where L is the length of the room in feet. Find the actual length of the room. Okay, so we have, it's not set equal to 0. So when we multiply this, this is a quadratic equation, but we have to get it set equal to 0. So L times 3L is 3L squared. L times a negative 7 is a negative 7L, and that equals 20. So we subtract 20 from both sides. 3L squared minus 7L minus 20 equals 0. All right, now we just learned the quadratic formula. I would use that. A, B, and C. Okay? So x equals negative b, or in this case, L equals. I guess we should change it to L. Okay? Negative b, which is negative 7 plus or minus the square root of negative 7 in parentheses squared minus b squared minus 4a, which is 3, and c, which is negative 20, all over 2a, which is 3. All right, so L equals negative 7 is a positive 7. 2 times 3 is 6. So I have 49 minus 12 times a negative 20. So get out of that and do, like I said, if you want to square the negative, make sure you put it in parentheses. Minus 4 times a, which was 4, times 3 times negative 20. Enter. It's 1,009. Okay, I don't know, second answer. Now, I have been saying that I want you to something's not right. I had an extra 4 in there. Sorry. All right, negative 7 squared minus 4 times 3 times negative 20. 289. My bad, I apologize. Second square root, second answer. Ah, that's nice. So that's 17. So that's plus or minus. All right, so we get L equals 7 plus 17 over 6, and we get L equals 7 minus 17 over 6. So we get L equals, that's 24 over 6 is 4. Okay, that's good for a measurement. But this is going to give us a negative 10 over 6. So this one doesn't make sense for it to be the length of a room to be negative 1 1/3, 4 over 6, 4 over 6, 2 over 3, 1 2/3, negative 5 over 3. That doesn't make sense for a measurement, so that's why it's L equals. Okay? All right. The area of a poster is represented by this, where W is the width of the poster. Find the actual width. Same type of thing. So we've got 2W squared minus 12W equals 32. We have to set it equal to 0. 2W squared minus 12W minus 32 equals 0. So I can factor a 2 out. W minus 6W squared minus 6W minus 16. And that factors. I can see right away that factors. So to give myself a little room, I'm going to move over here. So I've got 2. When you do your box, you'll get these factors, 8 and 2. That's a plus, that's a minus. That's a negative 8W and a positive 2W. It's a negative 6. Negative 8 times positive 2 gives you that negative 16. And we set each factor equal to 0. Okay, well, this one is not true, so we just X it out. So W equals 8 and W equals negative 2. We're talking about the width of a poster. Negative 2 doesn't make sense. So 8 is the one that we want. Okay? It says multiply these. Put it on the box and multiply it. On the outside, 2x plus 3, x minus 4. 2x times x 2x squared. X times a positive 3 plus 3x. 2x times a negative 4, negative 8x. Negative 4 times positive 3, negative 12. So our final answer, there's only one 2x squared rather. All right, we've got a negative 8 and a positive 3, so that's a negative 5x, and there's no other constant, so minus 12. Okay, find the equation of a line that contains these 2 points. Well, first thing we have to find is slope whenever you want an equation of a line. So 5 minus 2, okay, remember y2 minus y1 over x2 minus x1. So 5 minus 2, and then we have negative 4 minus 2. So our slope, that's a negative 3, or no, that's 3 over a negative 6. So negative 1/2 is our slope. All right. Now, I'm going to use the point slope form because it's just really easy. I'm just going to grab this one. Okay, remember that's y minus y1 equals m times x minus x1. So y minus 2 equals negative 1/2 times x minus 2. Okay, so y minus 2 equals negative 1/2 x plus 1. Okay, a half times 2 over 1 gives you positive 2 over 2, which is 1. All right, so I have to add my 2. So our final answer is y equals 1/2 x negative plus 3. Okay, Ben draws 3 marbles from a bag that contains 3 red marbles, 5 blue marbles, and 2 white marbles. Okay, so we're doing probability here. We have not talked a lot about this, but you add up everything that's in the bag. Okay, so that's 3 and 5 is 8, and 2 is 10. So there's 10 marbles. In the bag. Okay, he's going to draw 3, and he's going to, once he pulls it out and sees what it is, he's going to put it back in the bag. So the number of marbles in the bag stays 10. So we're going to have 3 different drawings. Okay, what is the probability that Ben draws a red on the first one, then a blue, that's number 1, number 2, and number 3. And remember, he pulls it out, he looks at it, he puts it back in the bag. So each one of these is over 10. Okay, so he wants a red one first. There's a chance of 3 reds, 3 out of 10. He put it back in the bag, so we're back to 10 in the bag again. He wants a blue one. There's 5 blue. He put it back in the bag. So there's still 10 marbles and there's still 5 blue ones. And he wants another blue. Now, all you have to do is multiply those 3 things. So we end up with 1,000 on the bottom, and 25 times 3, that's 75. And I believe math, enter. I don't think that, it does reduce to 3 over 40. Okay, put this in the calculator, math, enter, and you get 3 chances out of 40 that he's going to get a red one, put it back, a blue one, put it back, and a blue one, and put it back. All right, in the problem above, he does not replace the marbles. So every time he pulls a marble out, there's 1 less in the bag. So on number 1, you start with 10 marbles. But on number 2, then you only have 9, and then you only have 8 on number 3 in the bag. Okay, he wants a red one. There are 3 chances out of 10 that he's going to get a red. And he sets it aside. He doesn't put it back in the bag, so there's a total of 9 marbles. Now, out of that 9, there's only a chance of 5 blue ones. Okay? And he sets that marble aside. So not only is there only 8 marbles left in the bag, there potentially are only 4 blue ones left. Okay? So we multiply all that together. And you get 60 over 810. All right, so let's reduce that. 60 divided by 810, math, enter, enter. So 2 chances out of 27 that he's going to get a red, a blue, and a blue without putting them back in the bag. All right, so there's the story for quadratic applications.